to be explaining how to find how many mono, di, and trichloro derivatives are possible for cyclopentane. So this question is basically asking about how many isomers there are for each level of chlorination for the alkane cyclopentane. And I'll draw my alkane here. So the root is pentane, so it's 5 carbons. And cyclo just shows the geometry of pentane. Cyclo, you can think of it like circles, so there's going to be a cyclic structure of pentane. So my 5 carbons here are going to be in a cyclic structure like a pentagon. So that is my cyclopentane. There is a hydrogen bonded onto each of the carbons too. So what would happen if it was chlorinated if I added Cl2? First, it would go through monochlorination, so there'd be one chloride on the cyclic structure. So the hydrogen would be taken off and the chloride goes onto it. So you're left with the cyclopentane with a chloride on it, and that hydrogen bonds onto the other chloride that's on here. You're left with HCl plus your monochlorination derivative. And what would happen like if the Cl went onto another carbon? It's possible the chloride can go on any of these carbons here, but they're the exact same thing. This is equivalent to if the Cl was on top of here, so these would not be considered isomers. These would not be considered isomers because they would have the same boiling point, melting point, relative density, solubility. They're all the same. It's just like you flip this, you turned it around. So there's only one monochloro derivative possible for cyclopentane, and this is it. So now I'll move on to my dichloro derivative. So I'll start with my mono derivative, because when you introduce Cl2, chlorination will keep occurring until it goes into the third chloro derivatives. So now there's definitely going to be more than one spot that this chloride can go to. And excuse me, there should be 2 hydrogens on each of these now that I'm looking at it. All of these should have 2 hydrogens. Because the carbon needs 4 bonds to be stable. So there's your extra hydrogens. Because this chloride, it can go either onto this carbon here, so this will have 2 chlorides, or it can go to this carbon here, one of the carbons of the outside ring, and take off one of these hydrogens. So that's 2 different diderivatives just right there. So it could be either Cl2C you can have one Cl here and a Cl on the outside. Now looking at the ring structure, would it be different if my hydrogen was on this one? And the answer to that would be no. Relative to the space of this carbon here, they're both equidistant, so it's really just flipping it. However, if it was on one of these carbons here, it would be different because they have a different distance from this carbon. So that is another isomer right there. There is 3 dichloro derivatives for cyclopentane. And there they are. So one of the derivatives, you have 2 chlorides on that carbon, and another one, the chloride is on one of the carbons that's next to this one, the top one. And then in the third isomer, it's on the carbon that's 2 away from the one with the chloride. So that is all of the dichloro derivatives. So now the last one, the tri. So in this one, you're just going from one of the one of the diderivatives. So you're starting with the diderivatives and you're adding more chloride to it. So we could start with this one here. So where's all the spaces that this chloride can go to that will give a different isomer? One of them is here. So that'll be 1 carbon away from this, and the other is here, which is 2 carbons away. So that's 2 isomers right there. If it was on this one here, it goes on that one, and you added Cl2. What are the different places that it could bond to that would make it different? There would be this one here, which would be right next to it, so you have 3 Cl's right next to each other, or it can go on that one there, which would space it out, so there'd be a carbon in between them. And that would actually be all of the isomers for the trichloro cyclopentane. There'd be 4 different isomers. One, you have 2 Cl's on the top, and it could be either on the carbon next to it or the one that's farther away, or it can be derived from one of these 2. If all the chlorides were right next to each other, or if there was space between the 2 carbons. And that's how you find the mono, di, and trichloro derivatives that are possible for cyclopentane.